Today we're doing vectors and lines. Sounds easy, but can be tricky.
Such as what?
What's the difference between a vector and a line?
I assume a line starts and ends in a spot.
Not necessarily.
You can just move a vector around, but like line is in a spot. Like it.
Yep. So vector,
Has a direction and
it
magnitude.
has a direction and magnitude, but you can put it wherever you want on the page.
While a line
Does
has
that
a
make
start.
sense? So you can put the vector wherever you want. You can put it starting over here, you can put it starting over there. As long as it has the same magnitude, same direction, it's the same vector.
Does a line have a direction?
A line has a specific location. So a line, it can have two directions. A vector, it only has one direction. In one direction. A line travels in two directions. That's why when you have a line, you have two arrows. A vector, you just have one arrow. A line is infinite in length.
You know what? This could go in a table.
And a vector has, how can I say that? The opposite. Infinite length, finite length. So this is the equation of a line. Vector equations usually something like v vector xi plus y j. So today we're going to look at, now we've distinguished the difference between a vector and a line, we're going to look at the vector equation for a line. So if you think about a line, so it goes on forever, right? On that line, we could have infinite vectors relating to that line. So let's just start with one vector. Because it's the start of the alphabet, let's start with vector A. We have vector A, and it's on a line, right? Everyone see how it finishes at the line?
Yep.
Yep.
Much like.
Okay, and then we have, let's make another vector
Whoa.
that ends on the line. What are we going to call this one?
C.
But
We have two vectors that end on the line. We want to make this line into a vector equation. So the difference between these two vectors is called vector D.
D for difference.
Good job.
Uh,
C gets left out. So to find D, it would be
B A plus B.
No, it's B take A.
B take A. So if A was, I don't know, what do you think those coordinates are? Yep, negative 2i and 4. What do you think is B? 3 and 6. So we can express it like that or like that. Either notation is correct. Okay, I'm just going to stick with the columns because they're a bit easier. You don't have to worry about i's and j's.
you
Okay.
worry about the brackets.
So that would make, yes, thank you. So let's figure out what D is. b minus a. 3, so you do the i's. So 3 take negative 2.
5.
6 take 4, do the j's. So that's the difference vector.
Always write these as fractions.
Okay, let's just recap what we've done so far. So A is a known vector on the line. D is the difference vector. It is a vector traveling, if it's traveling in the same direction, what's that called?
A parallel.
Difference vector traveling parallel to the line. Okay, so we could have vector C, right? And it's a bit longer than B, it goes off in that direction. The difference between A and C is just some sort of scalar multiplication of that original D. So every vector on this line is a scalar multiplication of that difference. So the difference between A and any other vector, literally any other vector on the line, is you add the scalar difference. So it could be, 2 times D, and then it's going off. It's bigger. Does that make sense? I'll show you. The equation for the line now is this. A known vector on the line plus a scalar multiplication times the difference vector. So if we want to find any vector on that line, R, you do a vector A plus some sort of scalar, could be 2, could be negative 2, could be negative 1,000, times the difference between two known vectors. Terminology, R is the position vector at any point on the line. K is a scalar, in case you didn't figure that out, so it has no direction.
Is C.
Okay, move on. Let's do an example. So, determine a vector equation in the two-dimensional space for the line passing through points A and B. Any thoughts what we do first? Perfect. So the unit vectors, so this becomes negative 2, 2. This becomes, because this is just a point and this is just a point, we're going to turn them into vectors. Does that make sense? So I'm just writing it like that. Again, if you want to use i's and j's, write it like this. Okay, so we have the two vectors. So we can also call these A and B if we want. We've turned our point into a vector. Now what do we do? Yep. Three, negative 5, minus negative 2, 2. You could also write it like this. And the last step, it's pretty tricky. No. Use that equation I gave you. So R equals A plus KD. So the vector equation for a line is the A plus the D. Ta-da. This is the vector equation. Wasn't. So let's find the vector location of the point on the line if the parameter k equals 2. So pretty tricky stuff, guys. Are you ready? What do you think we do?
Subbing K with 2.
Well done. Alright. Okay, so you can also write it like this. Okay, and it's pretty much the same thing for 3D. You just have a Z or a K component. The thing to note, let's go back to this equation here. If we just look at the x's, so the x of r is equal to the a component plus k times the dx component, or the x of d. So the x of a and the x of d. Does that make sense? So the r value in x, or the x value in r, I mean, or any x on the line can be explained by that. So it's in vector form because it has vectors in the form, right? We can write this as column matrices like this. So this is the R. The R is a position vector, x, y, z. The A is a known vector. Let's just make it 1i, 2j, 3k. Scalar is just a k, and let's just make the difference, I don't know, -3, -2, -1. So we could split this up into 3 equations. Okay? We could just look at all the x's, right? It would become x equals what?
1 plus k3.
Yep, or 1
minus
plus
k3.
minus 3k. Okay? We can write y, someone else.
-2K.
Yep.
4K.
And z,
Either 3 minus 1k or just 3 minus k.
so we now have it in 3 separate equations for any x known on the line, any y known on the line, any z known on the line. So this is called, any guesses what this form is called? Please, if you've read it, don't say the answer.
Cartesian?
No, good try. It has a parameter in it,
Parametric.
parametric form. So this is useful if you just want to know the x, just want to know the y, just want to know the z. Okay? We also can rearrange each of these equations, so it's just k by itself. And now all of these are equal to k.
Equals form.
There's no parameters, there's no vectors, there's an x, y, and a z. Cartesian. Now, why is Cartesian form useful?
Because it's easier.
It could define a whole line.
Because we can see if we sub in a point, x, y, and z, they have to all be equal. Does that make sense? So you can find out if a point is on this line using the Cartesian form. So write yourself a note. It's on the line. Please write this down and put a bubble around it so in 6 months' time you'll remember this. This one is useful. What did I say? Parametric, if you want point for a k value. And this one is useful if you just want the equation of the line. Okay, so those are the 3 forms. They all have different uses for different situations.